Hello everyone, welcome to my channel. So now we are going to do Leetcode weekly contest. Second question, which it states that it is a easy level question. Okay, so here let us go ahead and check first about the reading part for this particular question, then considering examples, and finally the coding part. So let us first read this question. So here we are given a zero index permutation n, a permutation of n integer in this num, then a permutation is called a semi-ordered if the first number equals to 1 and the last number equals to n. You can perform below operation at as many times as you want until you make num a semi-ordered permutation. And semi-ordered permutation definition is that the first one should be 1 and the last one should be n. Pick two adjacent elements in the nums and then swap them. So we are required to return the minimum number of operation to make num the semi-ordered permutation. And that thing is required to be done as in this. Here, what we are required to do is we need we basically need that at this position one should be there and this position length of the array should length of this particular nums array should be there, that is 4 should be there, and we can only swap the adjacent one. That is what is mentioned. Now comes the part that how we can do this question. Let's, but before that, let us take the constraint. So here constraint is that length could be up to 50 only and each number could go up to 50. So basically n square solution could easily work here, but we have better solution as well for this. So now here if we see if we want this one here and here we want this 4 here. So now in that context how we can do is we are required to check that what is the first occurrence of 1 and what is the first occurrence of an end element. Means basically n here is length of the array. So after taking that, what we need to do is we just need to add the first index which is there, first index plus the last index. Last index in the sense this particular element index that we need to add, but that we can't add directly because the thing is that what we require is we need to swap this to this particular, right? Means we need to take it to the first and we need to take it to the last. So in that context, for this particular element, we require n minus the present position of this minus 1. That is the number of swaps we would be required for this 4, right? So in that context, what we need to do is we need to first minus n minus 1. We need to subtract this last index from this n minus 1. That is the thing which we are required to do. But there is one more twist in this question. That is that if Rn is before R1, then in that context, we are required to subtract from n minus 2 rather than n minus 1. And by that case is, see, here when we go, here 1 and 4 would be swapped, right? So in that context, one swap is done. And then when new array would be 2, new array would be 2, 1, 4, and 3, right? So till now one swap was done because we were required to move it here and move it here, right? So in that context, now only this swap is required to be done and this swap is required to be done, right? Only 3 swaps are required. But as per our previous formula, it was like we are doing 4 swaps, but that was not the case because when we are having this 1 and 4, something like this, so one swap would be reduced by swapping itself to make them to come to such a position so that they can easily move to their respective position which they are required to move at the end. So that is the thing, and that's why we are required to just subtract 1 from whatever swaps we are doing. So this is the one twist in this question, else this is a straightforward mathematical question. Now let us do the coding for the same. So here we are taking first index, last index, and n equals num dot size. Just for convenience, convenience, we are taking like this, and then answer equal to 0. Just declare, just initialization and declaration of the variables. And here now we are just here that is order of n times what we are doing, whatever it is. So now here we are just traversing our nums. And in this, we will be checking if a nums of I is equal to 1. So that would be our first index. And nums of I equal to n. So that would be our last index. And then we need to check that if first index is greater than last index, then in that context, we are required to do this particular step as well. Else, we will be just subtracting the last index from our n minus 1 and adding that to our first index. And this would be our answer. So this was all for this particular question. Now comes the part for time complexity, that here we can clearly see that it is order of n. Here it is just if else, so it is nothing. So just time complexity is order of n, space complexity is order of 1 because we are not using any extra space in the same. So this was all for this particular question. If you have any doubt, you could comment that down. So yeah, thank you.